Bonjour. It is my pleasure to announce Thomas Boyer-Chammard, to introduce him, to speak to us on sending rovers to Mars with Jupyter.
Hey, can we, okay, we're good. So I wanted to start with a little show of hands, maybe. How many people here are mainly using Jupyter for things that are not related to data science, scientific computing, or educational? So if you're using Jupyter for things that are not that, can you raise your hand? Okay, we've got a couple people, but not that many. The point I'm trying to make is Jupyter is really popular in three fields: data science, scientific computing, education, and for good reasons. Jupyter is an amazing tool, but there's no reason to stop there because Jupyter can do so much more. So what I want to share with you today is our experience at JPL of using Jupyter as a multi-domain engineering tool, and maybe, hopefully, spark new ideas on how we can use Jupyter for pretty much everything, and open up Jupyter to new domains that could vastly benefit from it. So quick outline of what we're going to be speaking about. I'll just introduce quickly what is JPL, what do we do, and what our Jupyter ecosystem looks like on lab, what we think the strengths are of Jupyter specifically for engineering practices. Then I'll go over some of the use case we're using Jupyter for, and finally some lessons learned and what we want to do next, both as JPL, but also as part of the Jupyter community. So a quick intro, what is JPL? So JPL, the Jet Propulsion Laboratory, is part of both NASA and Caltech. It's a federally funded research and development center that's owned by NASA, funded by NASA, and operated by Caltech. We are located in Los Angeles, California. You can see our campus here in the middle. It's a fairly large campus. There's a lot going on. I think we have almost 8,000 employees now. So there's a lot going on. But the main thing JPL focuses on is robotic space exploration. So if you've seen those Mars rovers, you have a picture here on the left. That's JPL's clean room. That's where NASA builds them. Here's just some other contributions. So we've had the first soft landing on both the moon and another planet, being Mars. JPL also built the Voyager probes, which were the first man-made objects to enter interstellar space, which, by the way, 45 years later are still running and transmitting data. We've also had continuous presence on Mars since 1997 with our fleet of orbiters, rovers, and landers. More recently, we've had the first powered flight on another planet with our little Mars helicopter there. And in the future, by the early 2030s, we're planning to bring back the first samples from another planet, being Mars again, in a large mission campaign in partnership with the European Space Agency. But so how do we get there? How do we get from an idea, a mission concept, to actually landing things on Mars and operating them while they're there? And the real answer is it takes an enormous amount of things and people. And one thing it takes a ton of is engineering. Now, engineering is a fairly broad term, but basically all of the disciplines from design and modeling through simulations, all the way through to integration, testing, verification, and validation. So a ton of things. Now, the reason I'm bringing this up is because over the past couple years, my team and I at JPL have been pushing for adoption of Jupyter as a tool to facilitate and enhance all of those disciplines, the practice of all of those disciplines. And I'm hoping that by sharing this with you today, sharing our experience of doing that with Jupyter, we can start a conversation on how to make Jupyter really a first-class citizen, if you will, in the world of engineering tools, but also in so many other worlds that could benefit from Jupyter, from using Jupyter. So really quickly, our Jupyter ecosystem, so we have this central piece at the core, which is our Jupyter Hub deployment. We provide custom images and kernels with both in-house in-house, but as well open source extensions and extensions and packages is the word I was looking for. So that's our core piece, but we also have Binder Hub and ReviewNB. These things are kind of out of the scope of this presentation, but if you don't know what they are, I really encourage you to check them out because they're awesome. And then we also have NBViewer. So NBViewer basically, it's a website that serves notebooks as web pages. So with all the interactivity you would expect in a Jupyter notebook, with plots being interactive and all that, but just without the need for a Jupyter server. So you just click on a link and your notebook is rendered interactively. And we'll see how that can be useful for us. So all these components are tightly coupled to our internal GitHub enterprise. But then, because by nature you can execute code in Jupyter, you've got a ton of integration possibles. And so by integration, I just mean connecting with another service, exchanging data, and doing things together, really. And so here I just listed some examples. You've got like databases, storage solutions, modeling tools, testing tools, all sorts of things. My point is you can really connect to anything that has an API. And so at this point, you may be wondering, well, what else is new? Like if there's an API, you can connect to it. And yes, that's exactly my point. And let me elaborate on why this is so valuable, especially in our engineering use cases or engineering context. So what makes Jupyter so great? There's many aspects to it, and I think we can kind of all agree on those. First of all, you've got a really rich engineering narrative that's embedded within your code. Everything's very visual and interactive. You can have widgets and extensions to make it accessible even to the people who do not necessarily know how to code. Everything's highly customizable, and that makes it very intuitive in a way. It's also widely popular and supported. You've got millions of notebooks out there on GitHub. There's a huge open source community. If you're running into an issue, most likely there's someone who already ran into it before, and hopefully they fixed it for you. And then there's this last key feature that I mentioned. You can integrate with anything. You can connect to virtually any server out there on the internet, but also in your organization's internal network. Forget everything you know about Jupyter for a second. When you're working on large projects with large teams, lots of different people from different backgrounds, these 4 features together in a single tool is a literal gold mine. That's why I have this little thing here. Because all of the disciplines of engineering I listed earlier, they likely need their own specialized set of tools and skill sets to work with. And now, with Jupyter, you can gain so much value by efficiently just interconnecting these tools, or even simply create brand new ones within this visual, interactive, intuitive environment that allows for code execution. But it's not quite ready out of the box. And that's why I really like this gold mine analogy, because you're not going to find that pure gold bar laying on the ground in your gold mine. You kind of have to work for it. You have to mold it. You have to shape it for the purpose that you want it to be used for. And that's really what Jupyter is. You can make great, yet simple to use solutions to answer basically all of your needs. But you do need to put in some of the work to make it happen. You have to create that holy notebook that'll do exactly what you want it to be doing. So since we've realized that, we at JPL have been coming up with interesting usages of Jupyter that I think everyone can apply in their own organization. So let's see what some of those are. The first one is testing procedures. So to provide some context, we are sending rovers millions of kilometers away, and you really only get one shot. You can't go there and fix stuff. So for that to happen, you need very rigorous testing campaigns. And at a very high level, a test procedure is basically just a document with steps to follow. And people are going to be authoring these documents, and other people are going to be running them. So for example, here we have these little animations, well, GIFs here are just like some tests. So you've got a driving test on the bottom side, and that's the sample caching test on the top. And so these people are running through test procedures as we're seeing them. But at a very high level, an example test procedure could be, well, first you need to set up your environment. You need to set up your test bed to be able to actually communicate with the system under test. Then once you're done, step 2 could be actually sending your command to perform what you're trying to test. Step 3 could be there's some observation that needs to happen. Make sure nothing breaks, maybe pull the plug on something if things get out of control. A fourth step could be analyze your test data, maybe do some plotting, and then you have to archive these results. So that could be just a fancy way of saying, take this log file, put it there, maybe do some copy pasting, maybe add some, well, probably add some comments on what happened. So this is just like an example. But as you can see, there's a lot of manual steps happening. And it's not necessarily bad, but let's say it calls for improvement. So one way to improve this is, imagine if your test procedure document is actually a notebook. Well, now everything can happen as part of the notebook. Steps 1 and 2, well, you can just have that be code cells within your notebook. Step 3, observation. You can have exhaustive markdown with pictures. Hey, look out for this, look out for that. Step 4, analyze. Well, that's probably the thing Jupyter is the most known for. So you're just going to be doing some really fancy plotting of that. Step 5, archive. Well, you can get fancy, do a lot of API calls to archive your results somewhere, but mainly, your main test artifact is just your Jupyter notebook, because that's where everything ran, that's where everything, like all of your results are going to be in. So this approach is exactly what we have been implementing. So because test procedures follow this very rigorous workflow, we have special requirements that Jupyter by itself cannot really address. So we made a custom extension for this. Our first requirement is you need 2 notebook interaction modes. You need an authoring mode where authors of the test procedures come in and just create their test procedures, much like you would create a notebook. You just add cells, add your steps, everything. Once the author is happy with their test procedure, they can export it in this execution mode. And that's where your operator comes in and run their test. So at this point, the notebook needs to be frozen, because you don't want to mess with the test procedure because it was so carefully authored. So the things you do is you execute the cells once and in order, and at execution time, you want to save additional metadata. So you have comments, the time at which the step was executed, and all sorts of things. So this is what it looks like in the authoring mode. So you can see that it's pretty much just a notebook, but there is this additional thing, which is a toggle between 2 cell modes. So cells can be either step cells or inform cells. So a step cell this is where you're actually performing a test step. So it could be maybe execute this command, send that thing, but also it can be just like rich markdown. So look at this, make sure nothing blows up. And then you have inform cells, which it's really anything that's not a test step. So it can be just explaining what we're going to be doing. Hey, you should be looking out for this, looking out for that. Still on the author side, once they're happy, you can export. Apologies. Export your test procedure in this execution only mode. So here we're on the operator side. So you can see the interface is quite different. Here you don't see which cells are steps or informative. You only see that the step cells have this little toggle on the left. And what that makes, what happens here is operators have the ability to run these step cells by what we call signing off on it, which is basically, it's going to prompt the operator for their username and record the time at which the cell was ran. And this information gets permanently preserved in the cell metadata, so in the JSON. So this is, you can just perform your sign-offs in a nominal execution flow, I would say. But we do accept that sometimes there's going to be deviations from that standard procedure. Maybe the network had an issue, maybe your configuration file was out of date or something. So in this case, operators have the ability to create what we call a red line. So a red line is basically just duplicating a cell, allowing the operator to edit that duplicated cell and rerun it with a comment as to why that was needed to rerun the cell. So this is basically so there's more to it, but these are kind of the core features. And this is what a test procedure could look like. So it's a substantial document, and lots of it is really just text. It just happens that you can also run code within it, which is really awesome. So to sum up, we're using Jupyter to integrate the narrative involved with each step with the corresponding code snippet or script to programmatically execute the steps and make everything more automatized, streamlined. I quickly just want to add one more thing before we move on to the next use case, which is we're using this for testing, but all we're doing is enforcing a really rigorous procedure as to how you're going to execute this notebook and saving some metadata. So this could really be used for anything that requires traceability of execution. And one thing I'm especially thinking about is, for example, DevOps. You could have a notebook where you're like creating a couple of machines in the cloud somewhere, deploying things onto them, maybe testing some things. There's no reason you couldn't gain value out of using these kind of things. No real transition here. It's just, this is the second use case I want to speak to. And this is the prime example of using Jupyter as an integration platform. So by that I mean use Jupyter to bridge the gap between all your services that are not necessarily connected with one another. And so this allows to streamline many things. And we have a lot of different examples of this. I chose modeling because it's kind of the most visual of them all. Don't bother reading the text. I should have scratched it. But basically, on one side, you might have your physics-based modeling tools. So these are tools that do great simulations of the physical behavior of your system. So that can be mechanical, thermal, electrical, all sorts of things. And those do great analysis with rich visualizations, plotting. Those are like essential to your design flow. But these are also complex tools to use and understand. And pretty much it's just the engineers building them that have the ability to understand them. So you do need a way to report on those analysis, create documents summarizing them, and yeah, just report back to the other stakeholders. This is the same idea, system level modeling. It's just a different approach of modeling where you model more the behavior of your system, the states it's in, just the system level structure. It's the same idea. It's a very complex tool to use. There's no narrative, and you need to create documentation. And then on the other side, you have your actual engineering documents. So those are very rich and interactive. It's not just PDFs. And they're more easier to understand and more consumable. And here, narrative is key, but there's nothing else. It's not a modeling tool. So you need a way to take your analysis from these other tools and publish them to these documents somehow. And that's where Jupyter comes in. What if you were to use Jupyter as this intermediary between all these components we just mentioned? You can be within Jupyter, pull in your models, make these analyses happen by connecting to your modeling tools, maybe tweak some simulation parameters, rerun some simulations, do all sorts of analysis. And then your simulation artifacts can be either publishing plots to these engineering documents, but also your Jupyter notebooks itself. Your Jupyter notebook itself is a document, which is fairly consumable. Here's what it would look like within Jupyter. It basically allows for like easy trait studies. And trait studies is where you do analysis, making the physical architecture of your system vary a little bit and see how that goes. So here you can kind of see that you've got two very similar curves that are not exactly together, and I think in this case, it's the wheel size that was changed, but anyways, you get the idea. What happens if I tweak things a little bit? And so, because you're in Jupyter, it allows for fast reporting on these trade studies. You can publish your plots and analysis rather easily, and here you're on the engineering document side, where you just published your analysis. We're kind of getting a little far from Jupyter here, but what I really want to emphasize is that we're using Jupyter as this integration platform. And there's always going to be vendor-specific tools that kind of integrate services together, but with Jupyter, you can really integrate anything with anything in like one-to-many, many-to-one, any way you'd like. This last example is actually my favorite because, first of all, I think it's probably the most applicable by everyone, and it's also fairly easy to implement. And it also happens that prototyping this was kind of one of my first tasks when I first joined JPL a couple years ago. So here, the need came from another subsystem in the Mars 2020 mission, which was the Perseverance rover. As part of surface operations, so what do you do once the rover is actually there? You do need to monitor the health of your rover, and you can't just go there and look at it. So we get a ton of data on a regular basis, a couple hours or so, and you need to analyze that data. And so these analyses will most often be the same. It could be, hey, what's the pressure on that wheel? What temperature did this sensor read over time? Maybe ring an alarm bell if things are getting out of hand. For these monitoring activities, you don't want your operators to go in every day, query the same type of data, run the same type of analysis. So what's the most effective way to streamline this? We have homegrown ways, of course, but a simple solution could be, what if you take a little bucket and you just put in as many notebooks as you want in it. Then you have some kind of automation pipeline that just takes in all of these notebooks, inject them with the new data that just came in, run them programmatically, and then expose them for everyone to look at with something like NBViewer. So we proceeded to implement just that. And I just want to highlight, put a black box on this whole spacecraft situation. We're just in a situation where we have regular data coming in, and we need to run some analysis. So that's a pretty common pattern, I think. So to implement this, we used Papermill. So Papermill is a great tool that allows you to programmatically execute notebooks with the injection of some parameters. So we have on one side a repository where user can asynchronously come in and publish notebooks. And whenever there's new data that flows in from this telemetry that you're getting from the rover, there's an automation that gets triggered. And then you pull in all the notebooks from your template notebooks repository, feed them into Papermill, injecting them with basically a pointer to this new data that just came in, and then make all the computation happen and publish all the artifacts to some other repository. Then users can just come in and consume the results on demand. And so it happens that we're running in some kind of CI cloud environment, but you could even do this locally with a cron job. So just like setting up your laptop to run this kind of behavior regularly. So once this is done, you can just consume your artifacts within NBViewer, but maybe you don't even need that because you set up some alarm bells to tell you if things are getting out of hand. And that's it. So some lessons. First of all, extensions, extensions, extensions. If there's something you want Jupyter to be doing and it's not doing it out of the box, writing extensions is fairly easily and it's very much valuable. We also want to be leveraging the collaborative editing features of Jupyter. I'll just skip over this. And last but not least, as part of a Jupyter community, I think we should be on the outreach. We should be promoting Jupyter adoption to other domains that are not using it yet, if that can be my last comment. And I'll be happy to address any questions you may have.
Okay, are there any questions? Any questions? Yeah, I have a question. The test notebook extension, is that publicly available?
Not yet, no. There has been, we've been trying to push for making it open source, but there's quite a heavy process that goes to it. But if people are interested, I can definitely weigh in and push for the process to happen.
I could see where that would be very useful in a lot of domains. As you said, not just for testing, but any place where you have a set of procedures that requires a sign-off and data input.
Yeah,
it looks very useful. Anyone else? Do you want to come down?
Yeah, I guess I'd just add to that, because I definitely work in a company where there's like an engineering team that makes notebooks, and then there's lots of engineers that see it all as a bit scary and don't really want to interact with it. And having a way of letting those people execute things in a safe and controlled way, I think would be really valuable.
Yeah.
Any more questions? Yes.
Oh.
How has your experience been building Jupyter extensions? Because Jupyter has evolved a lot from like a classic notebook to Jupyter Lab, different versions, and it's been hard from an outsider. So I maintain one Jupyter Lab extension, and it's been painful to kind of move it across versions. So any tips around that, and how has your experience been?
So that's a very good question that I'm not really fit to answer, because I actually didn't take much part in the building of that extension. We have a pretty large engineering team, and I'm just here representing it. But I think, from what I've heard, it was fairly straightforward. The most, not painstaking, but the most important phase was just figuring out what we actually wanted to make. And once we had that plan, I think the process was fairly straightforward.
Any more questions? I think we have time for one more, if there is. Okay, thank you very much, Thomas.
Thank you.